Welcome back. Today we have a few learning goals and they all relate to unit rates. We want to compute unit rates associated with ratios of whole numbers and fractions. We want to represent unit rates using tables and graphs. And we want to use unit rates to solve problems. Let's get started with our warm-up by doing problem number 3 and problem number 4. And to use these to find a unit rate, all you have to do for number 3, you would do 48 divided by 3. For number 4, you would do 45 divided by 3. Those will each give you a unit rate. Go ahead and pause the video and hit play when you're ready to talk about the meaning of those unit rates you've calculated. You've hit play, which means you're ready to discuss the warm-up. 48 divided by 3 is 16. Well, what does that mean? That means if I'm buying meat at this grocery store, it costs $16 per pound. Maybe it's not meat, maybe it's grapes or coconuts, I don't know. But whatever it is, it costs $16 per pound. And number 4, we have 45 students to 3 teachers. 45 divided by 3 gives us 15. What does that mean? That each teacher has 15 students. Maybe there's 15 students in each class. How big is your class? Does that match? So we've done a warm-up. We've gotten started with unit rates. An essential question we're going to answer today is how can we use tables and graphs to represent unit rates and to solve problems? Well, let's get started on that. Here we have a recipe and we have a little story. The story says, Paige loves everything pumpkin. Pumpkin waffles, pumpkin hand soap, pumpkin chili, and now she's trying to make the perfect pumpkin smoothie and she's using this recipe. And here it is. She wants to experiment a little bit with this given recipe. She's got some questions. Here's the questions Paige is thinking about. First, she's asking, what ingredients can Paige increase to make the smoothie more pumpkin-y? What if she wants to make it less pumpkin-y? Take a look at this recipe and talk with your partner. You're going to talk for about 20 seconds. What could Paige do if she wants this to be more pumpkin-y? What ingredients should she add more of? Good discussion. I am sure that you and your partner chose the pumpkin puree, and you may also have chosen the pumpkin spice. Those are 2 ways that she could make this smoothie taste more pumpkin-y. What if she wanted to make it taste less pumpkin-y? What could she increase? Well, if she wanted it to be less pumpkin-y, she could add more ice. Then that pumpkin flavor would be diluted. It wouldn't be as strong if she added more ice. Maybe she could add more milk. Then the milk to pumpkin ratio would be higher. There would be less pumpkin for every part of milk. So the pumpkin flavor would be less if she added more milk. And there's different ways she could experiment too. Maybe if she added more banana, it would taste less like pumpkin. This is something Paige is going to have to experiment with, but it all has to do with the ratio of pumpkin to other ingredients. All right. So we've talked a little bit about ratios and about how we can use them to make a flavor stronger or to make a flavor weaker. Let's look at another example here, and we're using recipes again. Here we have 4 students share their recipes for lemon lime punch. The class decides to analyze the recipes to determine which one will make the fruitiest tasting punch. I'm going to give you a minute here. I want you to look at these recipes and tell me which one is going to be the fruitiest. Talk with your partner. That's your question. Which recipe will make the fruitiest punch? Hit play when you're ready to talk about this as a class. All right, you've hit play, so you're ready to think about it. I have made a table here because it's going to help me be organized. Let's start with Mason. What we really want to think about is how does the amount of lemon lime he's using compare to the amount of club soda he's using? Well, he has 4 cups of lemon lime concentrate and he has 8 cups of club soda. That simplifies to 1/2. Those are the same value. So about half of his punch is made up of lemon lime concentrate. How about Tyler? Well, Tyler has a ratio of 3 to 5. No simplification necessary here. That's a simplified fraction. Let's look at Carlos. His is 2 to 3, and Zeb's is 1 to 4. Let's talk about who has the strongest lemon lime flavor here. When we're trying to figure out which one is the strongest, what we're really saying is which one is the greatest ratio of lemon lime to soda. So that's what we're looking for here. In other words, the lemony limiest is going to be the one that's the biggest fraction. So which one of those do you think is the biggest fraction? It might actually help to put them in order. Let's start with Mason. Mason is right at 1/2. Half of his fruit punch is made up of lemon lime concentrate. Zeb at 1/4 is going to be over here. Let's write his fraction underneath there. 3/5 is a little bit bigger than 1/2, and I'm just using my number sense here. So that means Tyler's goes here with 3/5, and 2/3 is just a little bit bigger than 3/5. So here's Carlos with his 2/3. And we could actually use cross products to compare those if we wanted to. But for now, I've just listed them in order on a number line here. So let's talk about who has the fruitiest punch. That would be Carlos. This one is the fruitiest. Now, who has the least fruity? You're right. It is Zeb. This is the least fruity. Carlos's is the fruitiest because his ratio of lemon lime concentrate to soda is the greatest. Zeb's is the least fruity because his ratio of lemon lime concentrate to soda is the least. That's how we can use ratios to compare flavors. Now, I showed you the way that I think about it. I showed you Miss Johnson's solution. What I want you to do with a partner is to spend about 8 minutes, and I want you to set a timer, working through this problem right here. So what are you doing here? You're looking at Emily's strategy and Julio's strategy. You're comparing Julio's work to Emily's, and you're asking, in what way is their work different? How did they arrive at the same answer? They did arrive at the same answer. But how? Go ahead and talk with your timer. I'm sorry, don't talk with your timer. Go ahead and set a timer and talk with your partner. And what you're looking at is their work. How did they arrive at the same answer? And in what ways is their work different? Hit play when you're ready to talk about the next question. So you've looked at Julio's work and you've looked at Emily's work. And hopefully one thing you talked about is that when Emily did her comparison, she compared the lemon lime to each cup of club soda. Julio, on the other hand, compared his lemon lime amounts to the cup, to each total cup of punch. So he's comparing it to the total punch amount, where Emily's just comparing it to the cup of club soda. In this next activity, we are going to use Julio's strategy. We're going to compare the lemon lime to the total amount of punch made. And that's what we're doing down here. So that's why our bottom row has the total punch, and our top row for each table has the amount of lemon lime. Now, in order to do that, we're going to need to know the ratio of lemon lime to the total for each of these 4 recipes. Now, here's how we do that. We're going to have the amount of lemon lime in our numerator. So for Mason, that would be 4. And then on the bottom in our denominator, we're going to have the total. So 4 plus 8 is 12. 12 is our denominator. So 4 out of 12 is our ratio for Mason's recipe. I'm just going to write that as 1/3. For Tyler's recipe, we would have 3 in our numerator. And in our denominator, we would have 3 plus 5. That's the total amount of punch. So 3 cups of lemon lime to 8 cups total. 3 to 8 is our ratio there. For Carlos, we're going to have 2 in our numerator over 2 plus 3. That's 5. And for Zeb, we're going to have 1 in our numerator over 1 plus 4. 5 in our denominator. In other words, to make 1 cup of punch, Mason would use 1 cup of lemon lime concentrate. In order to make 1 cup of punch, Tyler would use 3/8 cup of lemon lime concentrate. If Carlos wanted to make a cup of punch, he would use 2/5 of a cup of lemon lime concentrate, and Zeb would use 1/5 of a cup of lemon lime concentrate. That's how we're going to start our tables down below. Now, as you are getting started with these tables, I'm going to show you a trick that'll make it a little bit easier. You get to choose the values in your table. Watch how I choose the values for Mason's table. I chose a 3. Let's see, 1/3 times 3. That's 1. 1/3 of 3 is 1. Now, what's 1/3 of 6? What if I had 6 candies and wanted to divide them between 3 people? That's the same thing as 1/3 of 6. That's 2. Okay, now what is 1/3 of 9? What if I had 9 candies and wanted to split them among 3 people? 1/3 of 9 is 3. Do you guys see how easy that was? And the way I made it easy was by choosing the denominator of my fraction in my bottom row there. I chose multiples of 3 because I had a fraction with a denominator of 3. That will make this work easy. So that's my little trick. Let's talk about what Mason's table is going to look like when I graph it on the line over here. So first of all, I had, let's see, the point when I had just 1 cup of punch. I was looking for that point for just 1 cup of punch, but you know what made it easier? Labeling my axes. 5 cups, 10 cups, 15 cups, 5, 10, 15. That's going to make this so much easier. Okay, now what we were doing. We were going to show that when we have 1 cup of punch total, from Mason, that's the same as 1/3 cup of lemon lime. So let's do that. 1 cup of punch is 1/3 cup of lemon lime. That's that point right there. Now let's talk about what happens when we have 3 cups of punch. That would be the 0.31. When I have 6 cups of punch, that's the 0.62. And when I have 9 cups of punch, that's the 0.93. So these are just the values from my table. I have 1/3 right here. I have 3/1 right there. I have 6/2 right there. And I have 9/3 right there. And the neat thing about these points is they form a proportional relationship, which means I can connect them with a line that goes through 0, 0. There we go. So that's how Mason's amount of lemon lime increases in proportion to the amount of total punch he makes. Let me label that. So we're going to pause the video here, and you are going to work with a partner for about 15 minutes. Your job is to finish these tables and then to take each table and use it to make a line. So pause the video and do not hit play. Not for at least 15 minutes, because I want you to do some high quality, thoughtful work with your partner by completing these tables and using the tables to generate a line for each recipe that shows how the lemon lime compares to the total amount of punch. Okay, you've hit play, so you're ready to talk about this. Now, there's multiple ways you could have filled out each table, but your graph should all basically look about the same. Let's zoom in on that. So here's my graph. And what I want to point out is that Zeb's graph is the lowest. It's the flattest graph. It's not increasing very fast. When you get into algebra, you'll say that it has the smallest slope of all these because it's not very steep. What this means is that his is not lemon limey. This has a weak flavor. You can also use the graph to see which one has the strongest flavor. Remember earlier we said that that was Carlos, and you'll notice that Carlos's line is the steepest. It goes up the fastest. So Carlos's is going to have the strongest lemon lime flavor. So we've talked a little bit about what this graph means. Take a minute and just silently write down your thoughts. What does the steepness of each line represent? And how could you use these graphs to determine which recipe has the strongest lemon lime recipe? You know the answers. Take a minute in your mind to process it and to write it down. Pause the video, write for 2 to 5 minutes, and then hit play when you're ready to finish this lesson. You've hit play, which means you are ready for Talk the Talk. This is an activity that you will do with a group. What it asks you to do is to look back at the work we did earlier with Paige's pumpkin smoothie. You're going to use her recipe to answer some questions. And I would like you to work in groups of 3, maybe 2, groups of 2 or 3, and spend 8 to 10 minutes as a group answering these 2 questions. Be sure that everybody writes down their answers and be sure that everybody understands.